Time to show you how to do all your homework problems because I happen to want you to do good. Yes, I do. Alright, so here we have 1.4's homework assignment. So this is inverses of functions. This should be relatively quick for you guys to go through because a lot of it is simply tables and just flipping things around. I once again already have it pulled up on the screen here. So let's take a look at what you guys will be seeing when you pull up 1.4's homework assignment. The table shows a function and its inverse. Complete the table for the inverse of the function, then choose whether the inverse is a function and complete the explanation of your reasoning. So if my domain is 14 and my range is 16, remember we're just going to, if you see a table, you're just going to flip it. So 14 to 16, 16 to 14. 16 to 64, 64 to 16. 15 to 34, 34 to 15. The inverse, and now we just have to check our range. Do these repeat. 14, 38, 16, 66, 15. Is a function because for each input there's only one output. Actually what we should be checking is these. So 16, 36, 64, 8, 34. So we're good. Next question. Mapping diagram shows a function and its inverse. Complete the diagram for the inverse of the function, then choose whether the inverse is a function and complete the explanation of your reasoning. So we know we need, the first missing number of the diagram is -7, and the second is -3, and I just got these from over here. So we had -7 over here, -3 here, so that should have transferred over here and over here. The inverse is not a function because, as we can see, 3 goes to both -7 and -3. 9 goes to both -1 and 1. So the inputs 3 and 9 each have two different outputs. Number 3. Enter the inverse of the given function as a set of ordered pairs, and then plot the points of the inverse on the coordinate plane. Okay, so this is kind of cool. So we're just going to take each of these points and reverse them. So we have -6, -5. We're going to have -5, comma -6. And we had -2, 4, so we'll have -4, comma -2. We have -2, 0. It was 2, 0, so now we're going to have 0, comma 2, and finally it was 2, 1, so we'll have 1, 2. Alright, plot the blue points to represent the inverse set of ordered pairs. So we want -5, 6, -5, -6 goes right there, -4, -2, there, -2, 0, 0, 2, 2, 1, 2. All right. Looks like that's it. Enter the inverse of the given. Okay, so same question. Once again, we're just going to flip all of these. So we have -6, -5, -5, -4, 4, -3, 4, 3, 6, 4, and 6, 5. Alright, so -6, -5, -4, -3, that's positive 6 comma 4, negative 5, negative 4, 4, 3, and 6, 5. This one is actually the one that looks wrong. What point is this? So I plotted negative 4, negative 3. This is supposed to be 4, negative 3. That's what you get for trying to do it too fast. So guys, make sure that you're paying attention. Also, I should have been looking at this and I should have seen that there was no way that was right, because if you just draw a line here, you should just be flipping right over it. So this point I knew should have been over here. Find the inverse function, f inverse of x for the given function f of x. Okay, you guys know how to do this. Step 1, we have f of x equals 7x minus 8. Step 1, change f of x to y. Y equals 7x minus 8. Step 2, change x and y. X equals 7y minus 8. Step 3, solve for y. Using PEMDAS backwards, we know that this subtraction has to come over here as addition. X plus 8 equals 7y. We know that we have multiplication, opposites division. So, x plus 8 over 7 equals y. Final step is to just change y to f prime, or f inverse. So we have f inverse of x equals x plus 8 over 7. So let's get that plugged in. They've already given us the f prime, so we need a fraction, we need x plus 8, we need divided by 7. Alright, next question. Once again, same thing. They've given us f of x equals x over 5, f of x changed to y, switch x and y, PEMDAS backwards, divided by 5 means multiply by 5, change y to f negative 1, or f inverse of x. That's all there is to it. Number 7. Same thing once more. So, f of x equals x plus 1 over 6. Change f of x to y. Change x and y. Now, I know I said PEMDAS backwards, which would normally mean we would do the addition first, but because this fraction bar is over everything, there's an imaginary pair of parentheses here, so that's going to be done last. So we have divided by 6, so we're going to multiply by 6. Opposite of addition is subtraction. Change y to f inverse of x. 6x minus 1. On to number 8. Once again, the exact same thing. Find the inverse function for the given function. F of x equals negative 0.3x. So y, step 1, change f of x to y, change x and y, and now we're going to solve for y. We have multiplication, so we need division. X divided by negative 0.3 equals y. Now I'm kind of curious as to if they'll accept this as the answer, because then we would just change y to f inverse. But I don't think they will, and I'll show you why if they don't. So x over negative 0.3. They actually did accept that answer. However, let's pull up Desmos real quick, and I want to show you what I thought they would accept. I'm going to zoom in a little bit. We have x divided by negative 0.3. Let's replace x with 1 real quick, and I want to do 1 divided by negative 0.3. And we get this decimal here, but if we convert that, we get negative 10 over 3. I thought they were going to make us say that this was equivalent to 10x divided by 3, negative. But they didn't make us do that, so a little bit easier than I was expecting them to make it for us. Alright, moving on. Number 9. The inverse function f inverse of x for the given function f of x. Oh, find the inverse. Use composition to verify that the functions are inverses, then graph the function in its inverse. Okay, so f of x equals negative 3x plus 3. Change f of x to y. Change x and y. PEMDAS backwards, so subtraction first. X minus 3 equals negative 3y. Divide by negative 3. We're going to get negative 1/3 x, or negative x over 3, depending upon how you write it. And then negative 3 divided by negative 3 is plus 1. Then we just change y to f inverse of x equals negative 1/3 x plus 1. A lot of different ways we could write this one. That's how I'm going to write it though, because that is the linear format that'll make it easiest to graph. So, negative fraction 1 over 3 x plus 1. They say use the composition to verify, but remember all that means is if I plug this into the equation that I get down here, that I just get out x. So if I have negative 3x plus 3, and then everywhere I see x, I'm going to plug this in. So negative 3x, negative 1/3 x plus 1 plus 3. Negative 3 times negative 1/3 x is just x. Negative 3 times 1 is negative 3. So I distributed my negative 3. Bring down the plus 3. X minus 3 plus 3. So f inverse of f of x equals f of f inverse of x, which equals x. So we've proven it. So let's graph our function first. This is a straight line. Our function is negative 3x plus 3. So our y-intercept is at 0, 3. And our slope is negative 3. So we need go down 3, 1, 2, 3, go over 1. Okay, so you have to click and hold between them. Graphing our inverse, we have negative 1/3 x plus 1. So we're right here. Negative means we're going to go down 1 over 3. 1, 2, 3. And there's our inverse. So you can see that they flip right over this line y equals x. That's why they put that line there. Number 10. Graph of a given function is given. Tell whether the function's inverse is a function and complete the explanation of your reasoning. If the inverse is not a function, tell how you can restrict the domain of the function so that its inverse is a function. Alright, we talked about this earlier. Absolute value functions don't have inverses. In order to make them have an inverse, you have to restrict their domain, at which point they're no longer absolute value functions, they're just lines. So the function's inverse is not a function because the function is many to 1. So you have many things that can go to 1. So both 2 and negative 2 go to 2. 1 to many would mean that the function itself was not a function. If the domain is restricted to x is an element of all numbers less than x, or x is all numbers greater than x, or some subset of these sets, the function becomes 1 to 1 and the inverse is a function. Graph of a function is given. Tell whether the function's inverse is a function and complete the explanation of your reasoning. If the inverse is not a function, tell how you can restrict the domain so that it is. Function's inverse is a function because the function is 1 to 1. So there are no repeated. Here's the easy way to do this. We have the vertical line test to tell if something is a function. We can actually use the horizontal line test to tell if something's inverse is a function. Alright, identify the domain intervals over which the inverse of the graphed function is also a function. Select all that apply. So, from 3 to infinity. If I go from 3 to infinity, keep in mind that we have an open dot here, so from 3 to infinity would include none of this left part. And that is a straight line, so we know that straight lines' inverses are functions. From positive 6 to infinity. Once again, straight line, so that's fine. Negative infinity to infinity. It's a straight line, but there's the absolute value effect here. So if we use the horizontal line test, then you can see that right here, it would cross twice, so that one's not going to work. From 0 to positive infinity, though, 0 starts here, and you can see that right at 0, we're at negative 3, and then at 3 we're also at negative 3, so that one's not going to work either, except for the fact that it says not including 0. So we actually don't include that 0, meaning it is going to work, because that's the only point that was made it questionable. 3 to 6, absolutely fine, no issues. 3 to infinity including 3. This one was 3 to infinity including 3. There is no difference. So they've repeated that one for some reason. I don't know why. Negative infinity to 3, not including 3. That's important. So negative infinity up to here, but without including that point. If that point was included, we'd have the same issue that we had before when we were talking about 0 to infinity. But because we're not including that point, it's just this line, so we're fine. And here is that question exactly. Negative infinity to 3, including infinity. Because including 3. Because it includes 3, it includes this point, and it therefore fails the horizontal line test right here. 0 to 6. So from 0 to 6, does it include 0? It does not include 0. So the only 0 and 3 are the only two that would be a problem, but they're not because it doesn't include 0. That one is a thought experiment for you guys. Make sure you're selecting all the ones that do work. Identify all linear functions that are their own inverse. The line y equals x is its own inverse. Also, any line that is okay. So yeah, if a line is perpendicular to this line, then when we flip over it, it doesn't change. So we need it to be perpendicular to the line, since it will be its own reflection across that line. So any linear function of the form y equals negative x plus b, where b is a real number, is its own inverse. So as long as the slope of the line is negative x, it doesn't matter what the y-intercept is, it will be its own inverse. Among linear functions, excluding constant functions, quadratic functions, absolute value functions, and exponential functions, which types of functions do you have to restrict the domain for the inverse to be a function? Complete the explanation. For the inverse to be a function, you have to restrict the domains of quadratic functions and absolute value functions, because these functions are many-to-one functions. For instance, the quadratic function pairs both negative 2 and 2 with 4, and the absolute value pairs both negative 2 and 2 with 2. Linear functions, excluding constant functions and exponential functions, are one-to-one, so their domains do not need to be restricted. And final question, number 15. Student was asked to find the inverse of f of x equals 3x plus 2. The student's work is shown. Complete the explanation of why the student is incorrect and what the student should have done to get the correct answer. The function of f of x equals 3x plus 2 involves two operations, multiplying by 3 and adding 2. The inverse operations are dividing by 3 and subtracting 2, so the inverse function is this. However, keep in mind that we do PEMDAS backwards when we're solving, and she divided by 3 and then subtracted 2, giving us the wrong answer. So since f inverse of f of x does not equal x, the student's function is not the inverse function. The inverse function should subtract 2 first, then divide by 3, making the inverse function. Let's go ahead and just do the math out. So f of x equals 3x plus 2. Y equals 3x plus 2. X equals 3y plus 2. X minus 2 equals 3y. X minus 2 over 3 equals y. Come on. Again, you could rewrite this to where it was 1/3 x minus 2/3 if you really wanted to get it into that linear equation form. Alright guys, we have successfully completed 1.4 inverses of functions. That is your entire homework assignment. So if you need more help, please find me in class or email me and set up a virtual tutoring session. Until next time, good luck, Wildcats.